Hi, everybody. It's Mrs. Clutch, and we are going to start some 8th grade standards. And today we're going to be talking about using the product rule and the quotient rule. So this is when we're dealing with exponents. It's going to be, I'm going to go through 6 different problems with you. It's going to be I'm going to kind of expand it, show you why it works, and then we're going to come back and you'll probably be able to pick up little tricks here and there. So I'm looking at the 8th grade exponents in scientific notation skills practice, which you'll see you have some problems in for homework today. So here's the first problem. It is, and I'm just kind of reading off my sheet, 2n to the 4th, m to the 3rd, times 19, n to the 2nd, m to the 9th. So this is the original problem here. Now, if I were to just write everything out as is, I would have 2 times n times n times n times n times m times m times m times 19 times n times n times m times m, 5, 6, 7, 8, 9. So now in this next line, I have written everything out. Now it's just going to be basically like collecting like terms. So if I look at, I can multiply my numbers. I have 2 times 19. So I've taken 2 and 19, and I'm going to make that 38. Then I have all of my n's. So you see I have 4 n's, 1, 2, 3, 4, and then 6 m's. So I have now n to the 6th. So I've used all my n's. Now I'm going to look at my m's. I have 3 m's and I have 9 m's. That's going to be m to the 12th. So can anybody see how we can have a little bit of an easier time doing this? If you just look at this, when you are multiplying the same variable to different exponents, you simply add the exponents. Notice we had n to the 4th, n to the 2nd, and that became n to the 6th. So I just did 4 plus 2. M to the 3rd times m to the 9th, end up getting 3 plus 9, m to the 12th. And all I did is multiply my 2 and my 19. Much easier, but this is why it works to do that. I kind of like to think about it like, oh, if I'm multiplying exponents, go down one step. Down one step from multiplying would then be adding. That's just kind of how I think about it in my head. It'll make a little bit more sense in a couple of days when we do exponents to exponents, why in my head I think go down just a little bit. So this is how we would do it when we are multiplying straight across. Now our next example is dividing. So this is number 2. So I have 17 k to the 5th, x to the 3rd, over 19 k to the 9th, x. So here's my problem again. Once again, I'm going to write everything out, and it's a little bit hard to do while I'm holding this, but I'm going to try. So I have 17 times k times k times k times k times k times x times x times x over 19 times k, 2, 3, 4, 5, 6, 7, 8, 9 times x. Just like we would normally do if we were simplifying this, if they match up, if there's one in the numerator and one in the denominator, I can cancel them. So I'm going to cancel this k and this k, this, and this k. And I'm going to cancel one x. So you'll notice I have 17 x squared left over 19 k to the 4th left. Let's look at here. When we're dividing, notice I had k to the 5th, k to the 9th. What did I do to get k to the 4th? Subtracted. And because there were more k's in the bottom, that in the denominator, that k stays in the denominator. I did the same thing for the x's. I have x to the 3rd and x to the 1st. So 3 minus 1 is 2. There are more x's in the numerator, so my x squared stayed in the numerator. Therefore, I can just subtract now. Dividing, one step backwards from dividing would be your subtracting. I can just subtract, and wherever there is more, that's where the variable and the exponents stay. This 17 over 19 cannot be reduced, so that stays as is. So if we look at number 3, so number 3 is 3n to the 5th z to the 9th times negative 5n to the 3rd z to the 6th. So I'm going to use the rule that I just learned. I can take my 3 and my negative 5 and make that negative 15. I have n to the 5th times n to the 3rd, which is going to give me n to the 8th. And I have z, because I added 5 plus 3. There would be, if I wrote it all out, there would be 5 n's here and 3 n's there, which would give me n to the 8th. And I have z to the 9th, z to the 6th. So that becomes z to the 15th. I always make my z with the line through it so you don't get confused with it being a 2. Much easier to do than the other way, and you go a little bit faster. So let's look at number 4. Number 4 is 15 w a to the 5th over negative 6 w to the 5th a to the 8th. Okay, so I'm going to do this. First thing, I know that there's one positive and one negative. So I know that my entire thing is going to be negative. So I'm just going to put that negative in front. I can take 15 over 6, and both of those are divisible by 3. I'm going to make that 5 here. And I don't know exactly where my variables are going to be. And I'm going to make that 3 here. Or I'm sorry, 2 here. So now I'm going to look at my w's. I have 1 w in the numerator, 5 in the denominator. So I'm going to subtract those. I need to leave that w where there are more of them. So it's w to the 4th. I have 5 a's in the numerator. I have 8 a's in the denominator. So in the denominator, I'm going to subtract them, and I have a to the 3rd. This kind of looks funky when you're writing it like this. Your answer normally would have the 5 in the middle, but this would then be the answer to number 4. The division is a little bit trickier than I think the multiplication. So I'm going to do one more of these for you. So I'm going to leave that one actually on here. So I'm going to do number 5, which is negative 5 m to the 9th d to the 4th divided by negative 11 m to the 3rd d. So the first thing I notice here is I have a negative and a negative, which means that my overall answer is going to be positive. So I don't even need to worry about putting the plus sign, but I know in my head it's a positive. I'm just going to make that plus sign there so I can keep. I know 5 and 11 cannot be reduced at all. So I'm going to keep 5 in my numerator and 11 in my denominator. I'm going to look at, I have m to the 9th in the numerator and m to the 3rd in the denominator. Subtract them, I have m to the 6th. More of them are in the numerator, so I need to keep that m to the 6th in the numerator. I have d to the 4th in the numerator and just d in the denominator. Subtract those, I have d to the 3rd, and they need to stay up in the numerator because there are more in the numerator. So d to the 3rd. We've assigned you 6 problems that are on here right now. It'd be great if you need to go back through and kind of match up what I've done to working on those problems, but we will have an answer key on here for you to look at. If you have any questions, please reach out to any of the honors math teachers. We're always here to help. And again, this is in the 8th grade textbook. Let me just kind of show you. Let me share the screen really quick. So here is the 8th grade textbook. We are in, just so we can get module 5, and it's topic 1. So here is the, if you want more practice than what we're giving you, just go ahead and go to module 5, topic 1, and there's a bunch of different problems that you can be working on. And you have access to this. All of you have your honors access in the Carnegie, on carnegielearning.com if you need to go to that and you want to get some extra practice. All right, hopefully that works for you guys, and we'll have more on exponents in the next couple of days. Take care. Have a great day. Bye.